Today we're going to learn about hypothesis testing. This is a way to check if something we believe in a group or like an average might still be true. We do this by looking at a data from a small sample and seeing if it matches what we expect it to be. This helps us decide which idea makes more sense. Is it the current belief or a new one? Now let's go over the basics. The first one is the null hypothesis denoted as H sub 0 and the other one is the alternative hypothesis denoted as H sub 1. The null hypothesis is the idea we already believe or assume. For example, the average weight is 368 grams. So now we assume or we believe that that is true, that the average weight is 368 grams. Now, in the alternative hypothesis, it is a new idea that we want to test. Since the first one, we already believe that the average is 368 grams. In the alternative hypothesis, to challenge the null hypothesis, we would say that the average weight is not 368 grams. In addition to that, there are also a few things that we have to remember in hypothesis testing. The first one is we only use a sample and not the whole population. Next is if the data strongly supports the alternative hypothesis, then we're gonna have to reject the old one or the null hypothesis. But if the data isn't strong enough, we don't reject the null hypothesis, but that doesn't mean that it is definitely true. Next is the null hypothesis always has an equal sign, but the alternative hypothesis never has an equal sign because that is what we are trying to show, that the alternative hypothesis is what challenges the null hypothesis. So how likely is it that the original idea or the hypothesis, null hypothesis, is still true based on our sample? An example is the Oxford Cereal Company believes that their cereal boxes weighs 368 grams on average. That's their null hypothesis because that's the result of their test that they made with their products. That's why they had the null hypothesis that their boxes weighs 368 grams on average. Now let's differentiate sample and population. Your sample is just part of the whole group, so which means it's just part of the population. And even if the null hypothesis is true, the sample average might be a little different or it might not be the same just by chance, and that is normal. So what does the sample tell us? Let's say your sample average is 367 grams, which is very close to 368, so you'd probably say nothing has changed since the difference is very little or very unnoticeable. But if your sample average is way off like 320 from 367.9, then you'd probably say something is different and reject the null. So how do we decide or how do we know what counts as close or different? Hypothesis testing helps by using math to figure out how likely your sample results, or if the original idea is true, or if it's not. Now, in deciding, we will be using distributions. To do this, we use known mathematical models like normal or t-distributions, which I think is very familiar already since it has been tackled from the last chapter. And this helps us decide if the sample result is usual or unusual.
Regions of rejection and non-rejection. Region of rejection. Rejection region, also known as critical region, is the set of all values of the test statistic that causes us to reject the null hypothesis. The region of rejection is the range of values for the test statistic that leads to the rejection of the null hypothesis. This region is determined based on the level of significance, which is the probability of making type 1 error rejecting true null hypothesis. So next is region of non-rejection. The non-rejection region or acceptance region is the set of all values of the test statistic that causes us to fail to reject the null hypothesis. The region of non-rejection is the range of values for the test statistic where we fail to reject the null hypothesis. This region lies between the critical values in the distribution and represents outcomes that are considered likely or consistent with null hypothesis. And the last is critical values. The critical value is a point or boundary on the test distribution that is compared to the test statistic to determine if the null hypothesis would be rejected. Critical values are the boundary point that separate the region of rejection from region of non-rejection. These values are based on the chosen level of significance, 0.05 or 5%, and the type of test is one-tailed test or two-tailed test.
Good day everyone. Today I will discuss the risk in hypothesis testing. Whenever we do hypothesis testing, there's always a chance we make the wrong decision. That's the risk in hypothesis testing. The first kind is type 1 error, where we reject the null hypothesis even though it's actually true. It's like sounds a false alarm. This risk is called alpha, and we control it by choosing our significance level. The second is type 2 error, which happens when we fail to reject the null hypothesis even though it's false. This is like missing a real problem, a missed opportunity to take action. That risk is called beta. The complement of these errors help us make stronger decisions. And confidence level 1 minus alpha tells us how sure we are that we made the right choice. Power of the test 1 minus beta tells us how likely we are to detect a real effect when there is one. So in this example, imagine a company fills cereal boxes with exactly 360 grams. We want to test if the machine is doing that correctly. Our null hypothesis is that the machine fills 360 grams, meaning it's working fine. The alternative hypothesis is that the machine is not filling 360 grams, so something may be wrong. So now here's the risk comes in. If we reject a null hypothesis, saying there's a problem but the machine was actually fine, we've made a type 1 error. We just made a false alarm. On the other hand, if we don't reject null hypothesis, saying everything's okay but the machine was actually faulty, that's a type 2 error. We missed the chance to catch a real issue. The chance of making a type 1 error is called alpha, and it's usually 5%. The complement of that 1 minus alpha is the confidence level. That's how confident we are in our conclusion. For type 2 error, the chance is called beta. The complement 1 minus beta is the power of the test, which tells us how likely we are to detect a real problem. So, in hypothesis testing, we always face this risk, but by setting alpha and increasing power, we make better and more confident decisions.
Good day everyone, I'm Julian Gabriel Aspelandas, and today I'm going to discuss to you the application of CPM. CPM or Critical Path Method help organizations plan, schedule, and control complex tasks. This tool is especially useful when managing projects with many steps and deadlines. This method helps reduce uncertainty, save time, and make sure everything runs smoothly. Critical Path Method is a project planning technique that identifies the longest sequence of dependent tasks. This is called critical path, and the shortest time possible to complete the project. If any task in this path is delayed, the whole project is delayed. CPM works best when projects with well-defined tasks and timeliness. Second is construction engineering projects. Third is software development projects. Fourth is a situation where task duration are predictable. Benefits of CPM are shows which tasks are critical and flexible. Second, helps in scheduling, managing resources, and avoiding delays. Third or lastly is, it makes easier to adjust plans and prepare for risk. So in conclusion for both PERT and CPM, these methods are both powerful tools for managing projects So CPM is ideal for projects with clear tasks and deadlines, helping avoid delays and improve planning, while PERT is better for projects with uncertainty, allowing more flexible scheduling and better risk management. Choosing between the two depends on the nature of the project.
Good day everyone, I am the Taurus Results and today I will going to discuss to you what is the hypothesis using critical value approach. So first, let us define what is critical value. So critical value, it is the cut-off point on the test statistics distribution. So it also helps us to determine whether to reject or accept the null hypothesis based on the observed test statistics. And also, it is very important in the agribusiness to know or to study what is the critical value approach, because it provides clear and objective method or data for making decisions regarding on rejecting or accepting the null hypothesis, so that the business can make more informed decisions on the resource allocations and best practices. So let's move to the decision rule. So there are two. So if the results of the test statistics is beyond on the critical value, which is less than negative 1.96 and greater than positive 1.96, so the null hypothesis is rejected. However, if the z-stat results is between negative 1.96 and positive 1.96, the null hypothesis is not rejected. So for example here, suppose that the sample of 25 cereal boxes indicates a sample mean 372.5 grams in the population standard deviation is 15 grams. So using the equation, the formula here is z-stat equals sample mean minus parameter over standard deviation over the square root of sample size. So 372.5 minus 368 over 15 divided by the square root of 25 equals positive 1.50. Therefore, the null hypothesis is not rejected because the result is between negative 1.96 and positive 1.96. Critical value approach to hypothesis testing solution. So first step is state the null hypothesis and the alternative hypothesis. Since our null hypothesis is not rejected man, so mag-stick yapon ta sa 368 grams. So mani ato'y butang dari Then next, choose the level of significance and the sample size. The level of significance is based on the relative importance of the risk of committing type 1 and type 2 errors in the problem. So dari naman ta sa type 1, so natay significance level of our alpha 0.05 and our sample size is 25 grams of cereals. Then the third one is determine the appropriate test statistic and sampling distribution. So atong gigamit here is the normal distribution. And then the fourth is determine the critical values that divide the rejection and non-rejection regions. So since our atong alpha is 0.05, the critical values are negative 1.96 and positive 1.96. Ang rejection region is less than negative 1.96 and greater than positive 1.96. Ang non-rejection region is negative 1.96 less than or equal positive 1.50 less than or equal positive 1.96. Collect the sample data, organize the results, and compute the value of the test statistic. So, ang atong sample mean is 372.5 grams. Then, ang atong parameter is 368 grams. So, mo to atong i-compute. Ang results then is positive 1.50. Then, the last one is make the statistical decision and state the managerial conclusion. Ang non-rejection region, muna din to negative 1.96, less than or equal positive 1.50, less than or equal positive 1.96. Then, ang conclusion is it is non-rejection, null hypothesis kay between siya sa kaning critical values. And then, therefore, the managerial conclusion is insufficient evidence exists to prove that the mean field is different from 368 grams. So another example here is the alternative hypothesis. So you are the manager of a fast food restaurant. The business problem is to determine whether the population mean waiting time to place an order has changed in the past month from its previous population mean value of 4.5 minutes. From past experience, you can assume that the population is normally distributed with a population standard deviation of 1.2 minutes. Use like a sample of 25 orders during a 1-hour period. The sample mean is 5.21 minutes. Use the 6 steps approach to determine whether there is evidence at the 0.05 level of significance that the population mean waiting time to place an order has changed in the past month from its previous population mean value of 4.5 minutes. In the solution, first step is state the null hypothesis and the alternative hypothesis. So the null hypothesis here is 4.5 minutes. Alternative hypothesis is opposite of the null hypothesis, so that the alternative hypothesis is not equal of 4.5 minutes. Step 2 is you have selected a sample of 25 minutes. Then the level of significance is 0.05 atong alpha man siya. Then step 3, ang atong standard deviation is already given naman siya, so gagamit ang normal distribution. Next is atong critical values is negative 1.96 and positive 1.96. Since kay ang atong alpha is 0.05, then the rejection region is less than negative 1.96 and greater than positive 1.96. Then ang non-rejection region is between the negative 1.96 and the positive 1.96. Then the fifth one is ang atong sample mean is 5.1. We compute using the formula the z-stat equals sample mean minus parameter over standard deviation divided by the square root of sample size. So 5.1 minus 4.5 divided by 1.2 over square root of 25, so equals positive 250. So the results is null hypothesis is rejected because ning lapas na siya sa atong critical value na positive 1.26. So that we can conclude here that there is evidence that the population mean waiting time to place an order has changed from its previous value of 4.5 minutes, and the mean waiting time for customers is longer now than last month. And as the manager, you would now want to determine how waiting time could be reduced to improve service. So that's it.
Hi everyone. Today, I'll be explaining hypothesis testing using the p-value approach and walking you through an example so we can understand how it works step by step. So first, let's define what is a p-value is. A p-value is the probability of getting a result as extreme as the one we observe, assuming that the null hypothesis is true. It helps us understand whether our sample result is unusual or expected. Here's the rule. If the p-value is greater than or equal to alpha, we do not reject the null hypothesis. But if the p-value is less than alpha, we reject the null hypothesis. Now, let's go through the 5 steps of the p-value approach to hypothesis testing. Step 1. State the null hypothesis and the alternative hypothesis. Second, choose the level of significance and the sample size. Third, determine the appropriate test statistic and sampling distribution. Fourth, collect the sample data, compute the test statistic, and find the p-value. Fifth, make the statistical decision and state the managerial conclusion. We have here an example problem. A bottled water company claims that the average volume in its 500 ml bottles is exactly 500 ml. A quality control inspector believes that the average is different. She selects a random sample of 40 bottles and finds a sample mean of 497 ml. The population standard deviation is known to be 10 ml. We are to test at a 0.05 significance level whether there is enough evidence to say that the average volume is not 500 ml. Now, let's apply the 5 steps of the p-value approach to hypothesis testing. Step 1. State the hypothesis. In our example, a water company claims that its 500 ml bottles contain exactly 500 ml of water. So the null hypothesis is mu is equals to 500 ml, and the alternative hypothesis is mu is not equals to 500 ml, meaning the average volume is different from 500 ml. Step 2. Choose the significance level and sample size. We set our significance level at 0.05 and our sample size is 40 bottles. Step 3. Determine the test statistic. The formula for the z-test is z is equals to sample mean minus hypothesized population mean over standard deviation divided by square root of n. The sample mean is equals to 497 ml. The hypothesized population mean is equals to 500 ml. The population standard deviation is equals to 10 ml. And the sample size is 40. So 497 minus 500 is negative 3. 10 divided by the square root of 40 is approximately 1.58. Then, negative 3 divided by 1.58 gives a z-value of about negative 1.90. Step 4. Find the p-value. We now find the probability corresponding to z is equals to negative 1.90 from the z table. P times z is less than negative 1.90 is equals to 0.0287. Since it's a two-tailed test, we multiply this by 2. P-value is equals to 2 times 0.0287 is equals to 0.0574. Step 5. Make the decision. We compare the p-value 0.0574 to a 0.05. Since 0.0574 is greater than 0.05, we do not reject the null hypothesis. So the conclusion is there is not enough statistical evidence to say that the average bottle volume is different from 500 ml. That's how hypothesis testing using the p-value works. It helps us make decisions based on data, and in this case, we do not have strong enough evidence to prove that the company's bottles are off from their claimed average.
A connection between confidence interval estimation and hypothesis testing. So, I discussed two important statistical tools, confidence interval and hypothesis testing. Both methods help us make inference about population parameters based on sample data. So, we'll explore how they are connected and how they can be used together in statistical analysis. And the next slide is purpose of confidence intervals versus hypothesis testing. So, confidence intervals provide a range of plausible values for a population parameter, while hypothesis testing assesses a specific claim about the population parameter. So, confidence intervals estimate the range where the true parameter value lie, giving us an idea of the estimate's precision. So, while hypothesis testing evaluates whether a specific claim about a parameter is supported by the data. So, both methods use sample data to draw conclusions about the population. Next is example scenario. So, testing whether the population mean field amount 368 grams. So, use the Z statistic. Z is equals to sample mean minus mean divided the standard deviation divided the square root of sample size. So, suppose you want to test if the average fail weight of cereals boxes differs from 368 grams, we calculate the Z statistic to determine how far the sample mean is from the hypothesized mean in terms of standard errors. So this helps us assess whether to observe difference is statistically significant. Next is confidence interval interpretation. So if 368 is within the confidence interval, do not reject the null hypothesis. If 368 outside the confidence interval, reject the null hypothesis. So a confidence interval provides a range of values consistent with the sample data. If the hypothesized value 368 grams lies within this interval, we lack sufficient evidence to reject the null hypothesis. If it's outside the interval, it suggests that sample provides enough to reject the null hypothesis. So, next is example data of confidence interval calculation. So, given data is sample size is equals to 25, sample mean equals to 372.5, population standard deviation is equal to 15, significance level is equal to 0.5 or 95% confidence interval. So, use formula is equals to sample mean plus minus the standard deviation times the standard deviation divided the square root of sample size. So, and Z stat is equals to 1.96 for 95% confidence. So, let's calculate the 95% confidence interval for the mean fail weight. We use the Z distribution because the population standard deviation is known. The critical value Z stat for a 95% confidence level is 1.96. So next slide is numerical computation. Margin of errors is equals to 1.96 times 15 divide the square root of 25 is equals to 5.88 confidence interval. So 372.5 plus minus 5.88 resulting interval is equals to 362 less than the mean and 378.38 greater than the mean. So the margin of error is equal to 5.88 grams. Therefore, the 95% confidence interval is from 366.62 to 378.38 grams. This interval estimates the range in which the true mean fail weight lies with 95% confidence. So, and the last is conclusion. Since 368 grams is within the confidence interval, do not reject the null hypothesis. So, these conclusions aligns with the result from hypothesis testing. And so, both confidence interval and hypothesis testing suggest that there is no significant difference from the hypothesis mean. This demonstrates how both methods can lead to consistent conclusion in the statistical analysis.
The t-test for the mean unknown is a statistical test used to decide whether a sample mean is significantly different from a known or assumed population mean that the population standard deviation is not known. Instead, the sample standard deviation is used and the test relies on the t-distribution. The test is especially used as small sample sets. So I will be discussing about the critical value. So the critical value is a method used a hypothesis test to decide whether to reject the null hypothesis by comparing a test statistical a critical value from a probability distributions like the Z or T distribution. So there are 6 steps about the critical value approach. So first is state the hypothesis or null hypothesis, assume no change or difference. Second one is alternative hypothesis. So represent what you are trying to prove. like three types of tailed. So two-tailed, not equal. Left-tailed is less than. Right-tailed is greater than. And the second step is choose the significance level or alpha. Uh, the the common values is 0.05, 0.01, or 0.10. Ang step 3 is calculate the test statistic, where is ang formula. Ang X is sample mean. Ang hypothesize sa population mean, sample standard deviation, and sample size. So the step 4 is determine the critical values. Use the t-distributions with a table with the n-1 degrees of freedom, or chosen ang alpha. Step 5 is make a decision. So compare the calculated t-value to the critical value. If t-critical value is reject null hypothesis, or otherwise fail to reject. And the last one is step 6. So step 6 is state the conclusion. So summarize the result in context of the problem. So example, there is sufficient evidence that conclude that the mean is different from. So a p-value is a probability of obtaining the statistic or a result at least as extreme as the one observed, assuming that the null hypothesis is true. So there are 5 types of steps. So first is state the hypothesis. Second is choosing the significance level. Third is compute the test statistics. Fourth is find the p-value, and the last one is make a decision. So first is these steps sets a framework of the test. So the first is, in other words, a large p-value indicates that the observed data is likely under the null hypothesis. So you do not reject the null. So the p-value is not the probability that the null hypothesis is true. It is a conditional probability. So sample results. So example natin kuan mean example scores. So a school claims that average exam scores of a certain math test is 75. You believe that the average might be different, either a higher or a lower. So you conduct a hypothesis test. So first is state the hypothesis, a null hypothesis of alternative. So ang null hypothesis is equal. The truth mean is a 75. Ang alternative is not equal. So the true mean is not 75 sa alternative. So you take a random sample of 30. So 30 students. So sample mean is 72. So ang standard deviation is 10. Sa step 3 is conduct the test. You perform a two-tailed test and get the p-value. So ang p-value is 0.12. So step 4 kay find the p-value naman ta. So kung atong ikuan siya compare, so let us use a significance level of 0.5. So 0.5 atong gamiton. Since ang since ang common p-value is 0.12, so less than 0.05. So you do not reject the null hypothesis. So ang conclusion is there is not enough evidence to say that the average exams scores is different from 75. The data you collect is reasonably likely to occur even if the average scores is truly true of 75. So interpretation about the p-value. So if If the true average of score is 75, there is a 12% chance 12% chance you could get a sample of average as far as a 75 as the one you observe is 72. By just a random chance without like that. Checking the normalities assumptions. Explain when how to use the t-test, particularly when the population standard deviation is unknown. So the first one is use of the t-test. The t-test is used when you do not know the population standard deviation. Instead, you estimate of using a standard deviation with a S like that. So the second one is assumptions for the t-test. So the data must have a random sample from a normally distributed population. If the sample size is very very small and the population isn't highly skewed, the distributions works well from the approximate the sampling distribution. The third one is evaluating a normality. So you can evaluate whether the data meet the normality assumptions using several methods. So first is compare a sample statistic with the properties of a normal distribution. Graphical methods such as histogram, stem and leaf display, box plot, and normal probability plot. So, kani siya is nani siya last na to nga topic. And that's all. Thank you.
Now let's move on to the one-tail hypothesis testing. Now it is a type of statistical test used when you want to determine if a population parameter is either greater than or less than a certain value but not both. It is also called a directional test, focusing on a single direction of change from the null hypothesis. Well, unlike from the two-tailed test, which assess if there's any difference from the null hypothesis, one-tailed tests are used when there's a specific prediction about the direction of the difference. Now let's use the critical value approach in this one, where it is a method used to decide whether we reject or not reject the null hypothesis by comparing a calculated test statistic to a critical value from a statistical distribution, like the distribution here. Now we have an example. Determine if a new drive-thru process at McDonald's reduce the average service time compared to the old average of 174.22 seconds. Now we have 6 steps in determining by using our critical value approach. First is we state the hypothesis. Our null hypothesis H0 would be greater than, or our mean service time is greater than or equal to 174.22 seconds. While our alternative hypothesis, the H1, is the mean service time is less than 174.22 seconds. Now the next step is we collect the data. Now a sample of 25 stores is chosen. Now we have an N is equals to 25. Then we use the significance level 5%, which is denoted alpha or A is equals to 0.05. Now the step 3 is we use the t distribution, since the population standard deviation is unknown and the sample size is small, which is 25. Now the t distribution would be used. Now we assume that data is normally distributed. For the next step is the critical value approach. Now this is a left-tailed test, so we find the critical value of t for a 5% significance level, which is A is equals 0.05, with a 24 degrees of freedom. Now the 24 degrees of freedom, in order to solve this one, we have n minus 1, so 25 minus 1. Now our critical value is equals to the negative 1.7109. Now we were able to find this one to the t distribution table. So we have a picture flash on the screen. Now from a 24-degree freedom, we will find then the center of it from the 24 degrees of freedom along with the 0.05 level of significance, and that's where we will find the negative 1.7109. Now the next step would be the p-value approach. Now the sample mean survey time is the 162.96 seconds, and our sample standard deviation is 20.2 seconds. Now using the n is equals 25, our sample mean 162.96, and our standard deviation of 20.2 seconds, we substitute it to the formula. So flash on the screen the picture again. So with this, we will the total answer with this would be negative 2.7871. Now since negative 2.7871 is less than negative 1.7109, we reject the null hypothesis. So because our t-stat is, that would be our t-stat. So because our t-stat is equals to negative 2.7871, which is less than to the negative 1.7109, we reject the null hypothesis. So the conclusion would be that the mean service time at the drive-thru is less than 174.22 seconds. So there is no sufficient evidence to change the drive-thru process for the entire population of stores. Now, next is the p-value approach. Now, it is another way to decide whether to reject or not reject the null hypothesis. So, instead of comparing the test statistic to a critical value, we calculate a p-value and compare it to the chosen significance level. Now, the p-value is the probability of getting a test statistic as extreme as the one you calculated, or it can be more extreme. So, assuming the null hypothesis is true. So, a small p-value, usually less than the significance level, like 0.05 or 0.01, means our sample result is unlikely under the null hypothesis. So, you reject the null hypothesis. Now, a large p-value means your result could easily happen by chance. So, we do not reject the null hypothesis. Now, the steps of p-value approach, just like the critical value from the step 1 to 3, it's just the same as from the critical value approach. Now, the same example, right? So, we want to test if the new average drive-thru time is less than 174.22 seconds. Now, we have our sample of 25 stores. We have our n is equals to 25. We also use the t distribution because our population standard deviation is unknown. So, we now proceed to the step 4, which is find the p-value. So, we calculate our test statistic t-value, so based on the sample. So, let's say we get the t-value of negative 2.7871. So, in this case, our p-value is 0.0051. So that's the probability of getting such a low result just by random chance. Now, this next step we would compare the p-value with the A, which is our significance level. So our significance level is 5%, right? Which is A is equals to 0.05. So which means we're okay with a 5% chance of being wrong when rejecting the null. Now, we will compare. So, our p-value is 0.0051, while our alpha, or the significance level, is 0.05. Now, since 0.0051 is less than the 0.05 alpha, the result is statistically significant. So, we reject the null hypothesis. Now, the conclusion would be that there is a strong evidence that the new drive-through process is faster than the old one. So the result is unlikely to be due to chance. So it makes sense to roll out the new process to all stores. So we have the picture flash on the screens. Now we were able to understand what is one-tailed test using the critical value approach with the p-value approach. And also from the example, right? Now here's a summary of what are the important things that we need to remember regarding with the one-tailed test. So the null hypothesis, this is the starting assumption or the current belief. Now, it often states that nothing has changed or that the population parameter equals a specific value. So, the alternative hypothesis, this is what you want to prove with evidence from your sample. So, it suggests that the population parameter is either greater than or less than a certain value. Now, it is directional, meaning it points in only one direction, either greater or less. So, in interpreting results, now if your test shows strong enough evidence, you reject the null hypothesis and say that there's statistical proof for the alternative hypothesis. Now, if you do not reject the null hypothesis, this means that you do not have enough proof to support the alternative hypothesis. So, an important note would be that not rejecting the null hypothesis doesn't mean that the null hypothesis is definitely true. It just means that you couldn't prove the alternative hypothesis. So, parameter versus statistic. So, the hypothesis refer to a population parameter like the population mean. They do not refer to the sample statistic like the sample mean. And also, the sample is used to test the hypothesis about the population. I hope that's clear for us. So, that would be.
So the next topic is the z-test of hypothesis for the proportion. So the z-test for a proportion, which is used when you want to test a hypothesis about a proportion or percentage of something in a population. So what is it about? Suppose you want to know if the proportion of something like people who prefer a certain product in a population is a specific value called the hypothesized proportion. So to do this or to check this, first is you take a sample from a population, and then second, you must count how many people in the sample meet the condition you're interested in. And then for the third is you must calculate the sample proportion where P is equals to X over N, where the X is the number of people in a sample who meet the condition, and the N is the total number of people in the sample. And the fourth is, the last one is use the z-test formula to compare the sample proportion P to the hypothesized proportion. So the z-test formula is, this formula tells you how far your sample proportion is from the hypothesized proportion considering natural variation. So a larger z value means a bigger difference between your sample and what you expected. So you must have at least 5 people in both groups, those who meet the condition and those who don't. And this formula also has an alternative version. So this version is the same test but written in terms of X, the number of events, rather than the P, the proportion. So the next topic is the critical value approach. This topic explains how to test a hypothesis about a population proportion using the critical value approach with a z-test. So the scenario is a survey by American Express asked 2,000 adults if they wanted internet access while on vacation to check personal email. So the result is 1,540 out of 2,000 said yes, and the sample proportion is 1,540 over 2,000 is 0.77. Previously, it was known that 75% of adults wanted this. So, the goal is to test whether this year's proportion, the 0.77, has changed from last year's 0.75. This is a two-tailed test. So the step 1 is to set up hypothesis. The null hypothesis is 0.75. So the proportion has not changed. And then the alternative hypothesis is 0.75, the proportion has changed. And then the step 2 is determine critical values using the significant level 0.05 split between two tails, so that would be 0.025 in each tail. So from the Z distribution, critical values are plus minus 1.96. We check if the test statistic is less than negative 1.96 or greater than 1.96. So the next step is the step 3. So the goal of step 3 is we want to calculate a z-score, which tells us how far our sample result, the 0.77, is from the hypothesized population proportion, the 0.75, in terms of standard errors, where the sample proportion is 0.76 and the hypothesized population proportion is 0.75 and our sample size is 2,000. So the step-by-step calculation is first is to find the numerator. So our numerator is 0.77 minus 0.75 is equals to 0.02. This is how much the sample proportion differs from the hypothesized proportion. The second is to find the denominator. So our denominator is 0.0097, and to put it all together, we will going to have a 2.0656. So this means our sample proportion is a little more than 2 standard errors above the hypothesized value. So what does the z-score mean? A z-score of 2.0656 is beyond the critical value of 1.96 for a 5% significance level. So it's statistically significant, we reject the null hypothesis. So the step 4 is to compare and conclude. Since the 2.0656 is greater than 1.96, we will going to reject. So therefore, there is an evidence that the proportion of adults who wants internet access while on vacation has changed from the previous year, and it's now higher. So the next topic is the p-value approach. It is testing a hypothesis for a proportion using the p-value approach in hypothesis testing. So the situation is that a fast food chain introduced a new process to improve the accuracy of drive-thru orders. So the old process had a success rate of 85% or 0.85. So they tested the new process on a sample of 100 orders, out of which 94 were filled correctly. So they want to know, did the new process significantly improve orders accuracy or not? So here is a step-by-step process. So step 1 is set hypothesis. So we will going to perform a one-told hypothesis test, and the null is less than or equal to 0.85, then the new process is not better or the same. And the alternative hypothesis is greater than 0.85, then the new process is better. And then the step 2 is sample proportion. This is from the data, so the X is the 94, which is the correct orders, and the N is 100, the total orders. So the sample proportion is P is equal to X over N, so 94 over 100 is equal to 0.9. So the step 3 is to calculate the Z statistic. So what is a Z statistic? The Z statistic is also called the Z-score, helps you to understand how far your sample result is from the population value stated in the null hypothesis, measured in standard deviation. So it uses this formula for a proportion test, where the P is a sample proportion, the hypothesized population proportion is from the null, and the N is the sample size. So the step-by-step calculation is given that the sample proportion is 0.94, the hypothesized proportion is 0.85, and the sample size is 100. So we will going to subtract the sample proportion and the hypothesized proportion. So it's going to be 0.94 minus 0.85 is equals to 0.09. And then second, we will going to calculate the standard error. Calculate the standard error, and third is to compute the z-statistic. So what does this mean? So a z-statistic of 2.52 means the sample proportion 0.94 is 2.52 standard deviation above the hypothesized proportion 0.85. So this is quite far, and it suggests that the difference is statistically significant. And the fourth is to find the p-value. So for z, it is 2.52 and the p-value is 0.059. And step 5 is to make a decision. So the significance level is 0.01. Since the p-value is 0.059 less than 0.01, so we will going to reject the null hypothesis. And also, using the critical value approach, if z is greater than 2.33, and then we will going to reject the null hypothesis. And here is z is 2.52 and greater than 2.33, so again we will going to reject the null hypothesis. So therefore, there is a strong evidence that the new process has increased the proportion of correct field orders above 85%.
So, hi everyone, good day. I am Ashley Langgamin, and I am going to tackle about what is hypothesis testing pitfalls and ethical issues. So to this point, the other reporters already introduced to you what is the fundamental concepts of hypothesis testing. It is stated that we can use hypothesis testing to analyze differences between sample statistics and hypothesized population parameters in order to make decisions. We have also learned how to evaluate the risks involved in making this decision. So, when planning to carry out a hypothesis test based on a survey, a research study, or a designed experiment, we must ask several questions to ensure that we use proper methodology. So we need to raise and answer questions such as: first is, what is the goal of the survey, study, or experiment? How can you translate the goal into a null hypothesis and an alternative hypothesis? So kaning null and alternative hypothesis is introduced na siya by the other reporters. So second is the hypothesis test a two-tail or one-tail test? Third question is, can you select a random sample from the underlying population of interest? What types of data will you collect in the sample? Or are the variables numerical or categorical? So nakasulat, naka-indicate na diha sa PPT ang mga other questions. So failing to consider these questions early in the planning process, it can lead to biased or incomplete results. Proper planning can help ensure that the statistical study will provide objective information needed to make good decisions, business decisions. So next, we will tackle about the differences between statistical significance and practical significance. This one, we need to make a distinction between the existence of statistically significant result and its practical significance in a field of application. So sometimes, because of kanang large ang sample size, we may get a result which is statistically significant but little ang iyahang practical significance. So for example, ang nagbuhat og campaign ang expensive television commercial, which is ang result is 0.30 or 30% peoples ang recognized. And then after, nag-testing again using one-tail test, which results to now greater than 30%, which is in p-value of 0.0047. So, ni-increase ang people na nag-recognize sa brand. So, nag-indicate siya na it has statistically significance in brand awareness, but ang question is, nag-increase ba but ang question is, ang increase ba is practically important. So, it indicates that the increase is less than 1%. So, ang question na pod again is, did the large expense in marketing campaign is nag-result ba siya in increase in brand awareness? So, ang answer na is nag-increase siya but less than 1% lang. And because of that, we can conclude that the campaign is not successful. So, on the other hand, if the campaign increased brand awareness from 30% to 50%, we could say that ang campaign is successful siya. So now we have gone to what is reporting of findings. In conducting research, we should document both good and bad results. We should not just report the results of hypothesis tests that show statistical significance but omit those insufficient evidence in the findings. So last is what is ethical issues. So we need to distinguish between poor research methodology and unethical behavior. Ethical considerations arise when the hypothesis testing process is if manipulated siya. So some of the areas also where ethical issues can arise include the use of human subjects in experiment. So if human subjects ang atoang gamit for experiments, is kailangan yun ang consent sa human kay para makaproceed ta into experiments. Then also, ethical issues can arise in the data collection method, the type of test which is one-tail or two-tail, the choice of the level of significance, and also the cleansing and discarding of data, and the failure to report pertinent findings. So that's all. Thank you.